Uh, so I think I'll just introduce to us what is Numpy, and just like pandas, Numpy is a Python library, and this one is used for working with arrays. I think I introduced to you guys what is an array. Um, in Python, working with numbers it's quite slow, especially when you're dealing with large numbers. Uh, NumPy will help us in dealing with numerical large numerical values. So it has functions for working in for like in domain of linear algebra. I think if not all, most of us have heard of maybe linear algebra. So when it comes to linear, I think we all know here we're dealing with numerics. Um, so NumPy will just give us some functions or to work with large numbers, and that's why I'm talking of working with the domains of linear algebra. There is something called the Fourier transforms and also matrices. Um, just to give a brief introduction of NumPy, it was created in 2005 by someone called Travis Oliphant. Um, it is an open source project, and you can use it freely. When I talk of open source, it just means that it's a free what? It's a free library. You don't have to subscribe for you to use it. It's a that is why I'm calling it an open source. So NumPy itself is just is a short form for NumPy numerical Python. So that is num for numerical and py for Python. I think having said that, I'll just go direct to how we do installation of NumPy, and it's quite similar to pandas. We also use the pip. Uh, pip is uh, pip will help us to install NumPy, and for those of us who don't know what is pip, it's just this is a software that is it a software or is it pip help us to do something we call package management, and by package I mean these likes of the NumPy libraries and pandas and so many other libraries that Python has. So pip will help us to install those or manage those libraries. Um, so I think for those of us who are using the the VS code, you'll have to install the NumPy, and you're going to achieve that by what? By doing pip install and then NumPy. So this is the command that you guys you're going to use. But for those who are using that is Colab, you don't have to install it. Is already installed. And again, this it's quite similar to pandas. Also, how we import it, we just import NumPy as even np. You can call it. We can import Numpy as NP. So these things, they are quite similar. So I think you are not going to have so many difficulties as you are having with pandas, because this one is quite a repetition, but in a now different Python library. I think before I continue, maybe I don't know. Let me allow this. Let's wait for the others to join. I think you are still joining. I think for those guys who are using Colab and even Jupyter, I think you can just have an example of how to maybe to use maybe to create an array using NumPy and even print that. Let's wait for the others to join. So the first thing the first step so that you can use NumPy, you're just going to use the import NumPy as NP. Again, this one is a short form for NumPy. So NP, as you are having PD for pandas, and after that we can just define an array. I think we can just call it an array is equals to maybe NP dot array. Then maybe we can have even we can have a one-dimensional array. We can just have maybe a one-dimensional array here. Like 1, 2, 3. I think that is, oops, it should be somewhere here down, not should be here. So this is how we basically like create an array using NumPy, and I think even we can just print this just to see the output of this. Let me allow someone to join here. Yeah, so this is basically what we have. This is how we just create an array using NumPy. Let me just write a comment here. Creating an array using NumPy. It is just that simple to create a one. This one is a one-dimensional array, uh, and I think it is the what it is the basic form of an array. Just one dimensional array. We have a 2-dimension. We can have even 3-dimensional arrays. I think will come to we will come to that. So I'm hoping that everyone is able to create an array using NumPy, because I think it's quite easy to do that. Um, just using three lines, three lines of codes. You will have created an numpy array. So you first import numpy as np, and then you have that variable. You can name it whatever name you want. Just call it array, and then is equals to np, and then we invoke a method in numpy that is called array. Then we just pass our array here, which is 1 2 3, and even we have printed that. You guys are able to see this. So any question up to that point? Today I want us to move very fast because we are I feel like we are so much behind. We have a lot of content to cover within the short uh, period of time that we have. uh, I think that is basically that. So with importing and even creating just a simple with numpy. Allow someone here to join. So when you just import these, I think you can just read from here. When you import these now, it means that you already have that numpy in your system, and it's ready for use. And we go ahead and say that numpy, you can import numpy as np. um, np is just an alias, or even a shorthand of maybe numpy. So I think that is basically that. It's quite simple to create that. Let us create a numpy, an nd array object. Um, we are saying here that numpy is used to work with arrays. I think I've already said that. And the array object in numpy is called an nd array. So we are saying that an array object in numpy is called an nd array. So like what we have just created, uh, like this one is an nd array here. This one is an example of an nd array. This one, these are array. I think I can just finish up this name, call it array. So this one is an example of an nd array here, because we are saying that an array object in numpy is called an nd array. So this one is an array object. Um, so we are saying that to create an nd array, we can pass a list, a tuple, or any other array-like object into this array method. So I think we can have another example here. We can this time I'll just pass a tuple. I think you guys, you can create what is you can remember what is a tuple. And I think this statement is quite clear, because we are saying that to create an nd array, we can pass a list, we can pass a tuple, or any other array-like object into this function, and then it will be converted into an nd array. So an example of that is, let us just have an example of using a tuple, and you can see the first step is let me copy this to a new cell here. So the first step to do is to import numpy as np, And then the second step, um, you should have your variable name, or the name that you choose, the variable name you choose, maybe to hold the values of your ND array. So in this case, I'm using, let me just finish up this name. Let me just call it an array, which is equals now to, I'm invoking the NP, and the NP has that function we are calling array. Then I'll just pass it up. Hoping that you guys, you can remember how you are defining a tuple. You are just using parentheses, and then you can just pass values. I think I can delete these. So initially, this is the array function. So to pass the tuple values, I can decide to pass maybe 12, 13, can even pass 56, maybe 89. So whatever I'm going to print here now, it will be no longer a tuple, but an ND array. ND array. Just do that. So if I happen to run this is what I'm calling an ND array. But here we passed in a tuple. I think you guys, you can understand this. So any question up to that point? Any question? Uh, if there is no question, I think we can just move forward. To other concepts of Numpy here. So I think we can learn what are dimensions in array, and I'm saying that a dimension in an array is one level of an array depth, into bracket nested array. We're saying that a nested array are arrays that have arrays as their element. So this one is an array within an array within an array, yeah. So it is a nested. We see that it is a nested nested array. But before even we get to nested arrays, I think we can check the examples of all types of arrays, because I think we have quite a number. We can have the categories. We can have a zero dimension array, whereby we have an array with just one value, like in this case now here, where I have 42, where I have just 42 in my. Someone is requesting us to. I think someone is using the wrong link here. Just a minute. So we are saying in this case we have a zero dimension array. This is an array with just one value. Like in this case now we have just 42 is the value of this array. This one is what we call let me just admit this. We call a dimension array. We have one dimensional array, we have two dimensional array. I think we can just pass through them, and I think you'll note the difference. You'll note the difference. Let me. You just note the difference here. So in one dimensional array, um, I think someone's mic is on. Okay. So you're seeing an array that has zero dimension. D represent here dimension array as its element is called a unidimensional or 1D array. I think we can have that for an example here, whereby we have an array containing these values of 1 to 5. Um, we have it here. Let me just copy these somewhere. So let us have this one dimensional array here. Um, yeah, so remember the first step is to import the number as NP, and then we are just assigning the R variable to the values of these array here. So this one is just one dimensional array. Remember, a one dimensional array again, it just has one row of values, but it can have several columns. So I think you will note the difference when you get to two-dimensional array. But this is a good example for just one-dimensional array. Um, I think you can see this one is one-dimensional array. I think I can also add that message here to say that this one is a 1D array. So should be one-dimensional array there. So that is how we create a 1D array. So I think we can move to two-dimensional array. What is this? Yeah, let us just get to two-dimensional array. We are saying that an array that has one-dimensional array as its element is called a two-dimensional array. So this simply means that uh, we are just having a one-dimensional array as an element of a 2D array. So this one is what that means is that, as you can see here, I now have let me just complete this to be 4 and 5. So you can see that this one now, this one-dimensional array, it's an element of the 2D array, because I also have another I have another array in here. So I have it's like I have two arrays, two arrays within an array, and that is why we are talking of one-dimensional array being an element of the 2D array. So with this case, let us just try to print out these. I think with this I'll be able to explain something here. So let me just uncomment these and try to print these. That is 2D array. Yeah. So these arrays again, they should be of the same what? The same size. Let me add some other two values here. Are they 5? Yes. So here I have two rows of elements. So you notice that in row one, I have these values, that is 1 up to 5, and in row 2 now I have 4, 5, 6, and 8, 5. So meaning that the reason why we are calling two-dimensional arrays, because now we have now we determine like how to call these arrays based on the number of rows. Let me allow someone here to, okay. So if we have, like, let's say we have two rows, that one is a two-dimensional array. If we have now 3 rows, again that one will be now a three-dimensional array. And the trend continues up to when we can have maybe even 5-dimensional arrays. But most of the time we deal with up to 3-dimensional array. But you can have as many dimensional arrays as you want. So any questions so far? I think I should label this one as a two-dimensional array. 2D array. So any question? I'm hoping that I'm not too fast on that. But this is basically that. Let us see now a three-dimensional array. 3D array. Let us just see a 3D array here. We are talking of an array that has a 2D arrays as its elements. So again, now in 3D array, we are going to have a 2D array in it. So that's why we are talking of a 2D array being an element of a 3D array. So I think you can just have an example to illustrate that. So we are saying that to create a 3D array with the two-dimensional array, both containing two arrays with values of 1, 2, 3, and 4, 5, 6. So this is quite simple, because we just need these values. We are just going to repeat these, because now these values, I think I can use these up to this point. This is a two-dimensional array, right? So now adding another two-dimensional array, it's making it to be a 3D array. I think you can just try to print out these and see the kind of output you're going to get. But maybe we can be able to differentiate between the 2 and 3-dimensional array. Just print out this. So you notice here that I now have like they are like two-dimensional array. I mean two, how do I say it? Two-dimensional two is it two-dimensional array, two-dimensional arrays, or how do I say this? Let me just, I think I can do away with let me just do away with the first one so that it can let me have this. um, Let me just have this. That is 1 2. I think that yeah, exactly. This is what I'm looking for. So you notice here now I have how many rows of data. I have 1, I have 2, I have 3. So this one I have this one is a 3 by, it is a 3 by 3, is it a 3 by 3 matrix, this one. So where I have 3 rows and I have 3 columns, to mean that now I have, since I have now I have three I have 3 rows, to mean that I have this a 3-dimensional. This is a 3-dimension array. I think I can just label this a 3D array. A 3D array. I think that is all about the dimensions in these arrays. You can have even 4-dimensional array depending on the number of depending on the nature of the data that you are dealing with. But this is basically what we have in a 3-dimensional array. So any question regarding the dimensions of array? Any question? Any question? Winnie? Is there any question so far? Alvin? Yes, yes, Alvin. Any question? Oh, Alvin is saying is good. Um, Brianna, are we good with Harry?
Yes, I'm good.
Oh, okay. So after we have just check these dimensions of arrays, I think we can just learn how to iterate through arrays, and I think we can just start with the first, how to iterate through the first dimensional array, which is again quite easy using the for loop. I think these are just repetition of what you were doing. But this is how to iterate through an one-dimensional array. Um, if we had the one-dimensional array defined here. Yeah, this is the array. the one dimension array that we had. I think we can just, let me label it here. 1D array. So instead of printing the array now, we can just like iterate through this. I think you can just iterate through this. And to iterate this, I think we used for loop. So we can talk of for a number in this array of ours. We want to print that number. Then you can just you can just run this, and now you can see we are now able to iterate through these the values that we have here. So this one also applies with the two-dimensional array, and also with three-dimensional array. But let me just show you how to iterate through a two-dimensional array. Let me just copy these. I think we had yeah. See, I think we can just use these. And you should follow these, because this one you can see now we have two for loops, and one is this is what we call a nested for loop. So the first thing that we are doing here, we iterating through the first is it the first row, and that is what we are using for x in array to iterate through these through these through this first first row. So again, after now we have iterated that, you notice that we are left behind with the second part of values. So again, we must have again the y. You must have like another, you must have another for loop now to iterate now through x, and then so that now we can print, and the y now will hold all the values for all the values of this array. If I try to run this, you notice that I have managed to loop through these to loop through these values. But if I used, let me just show you. If I had used one for loop here, and I just do a print, just print x, you see I'm getting all the values here. I have now to go an extra mile to get into now iterating through these values, and that is why I'm using now the second for loop here to iterate now through these values. So it's just simple, and also this one will apply for the three-dimensional array. I think you'll see that we are now going to have several for loops. Any question on how we look to the 2D array? Anyone who needs clarification? Any question? I'm hoping that we are good. I think I can do away with that print, and we move forward to looping through the three-dimensional array right here. So we are talking about in a 3D array, we will go through all the 2D arrays. For example, iterate on the elements of how to iterate. How, like I think we have a good example here. We just have to iterate through this 3D 3D array here. I think with this we are going to have now we are going to have two nested for loops. I think you can just use this example here. Um, these are just basics. Uh, so you will apply them when needed. It's not a must you cram or how to iterate through these arrays. Let us just check through these. So the first thing that we're doing here is having the first for loop, like the one we had in to iterate the first dimensional array, and then we are having the first nested loop, a for loop here, whereby we are now iterating now through. We are seeing that for any number in x, I think I can take you step by step here so that we can see this. Let me just comment out this and try to print y. So you notice that, and I think I added this. This is not a three-dimensional array. I think I should do away with the fourth. Yeah, that is. Oops. Let me check this. Good. So let me just try to someone want to join. So let us see how to loop through this, and I think I've what. Let me just try to run through this again. I think we have already achieved. No, I think just try to print y here and see the kind of values that I'm getting here. So you notice when I have four loops, I'm getting now the rows. The rows in the rows in bracket, having the first, the second, third, and the fourth. We always start from zero, so it's 0 to 3. So you notice when I use the two for loops, I'll not have iterated through all these elements one by one, and that is why I need now that nested for loop here. And now to loop through, these values are stored in y. So I have again like to have another for loop to loop through these values in y, and then maybe store those values in another variable. And that's why I'm having now the third uh, the third for loop here. In this case, it is the second nested for loop. This one. So if I now and comment that and try to bring the values of z, you notice that I'll have now managed to loop through uh, each and every item, each at a time. So this is how we iterate through these arrays. It's quite for the 2D and that array, it's not quite straightforward, but with 1D array it's quite straightforward. But with 2D and 3D arrays, you have to have nested for loops in place for you to iterate through them. So I don't know if there is a person with a question on that. Before we move to something different. Any question? I think we can have. Yeah, I think that one example is enough. But I can have someone iterate. Let me just have this. I can have someone iterate through this for me. So any volunteer to. Let me just have Numpy. So I need someone who can guide me on how to look through this array. Any volunteer? Any volunteer for this task? Any volunteer? Can we have Alvin? Alvin,
Yes, I can hear you.
yes, I think you can help us to iterate through this.
Okay, you write the for statement for x in array.
X in array. So
You forgot the in.
in array, yeah.
Then a semicolon.
Yeah.
Then you write for y in x.
We can have for y in now x.
Then semicolon again.
Yeah.
Then for z in y.
For z in y now.
Then print z.
Print the values in z.
Yes.
I think, yeah, I think that is quite straightforward. So yeah, I think you guys we are together up to that point. Uh, let us just go through. I was to check something here. Any question? Yeah, Bedouin.
Sorry. It was by mistake.
Okay, okay, okay. I think I think we can check Numpy array slicing. We might need slicing. Yeah, so let us just check what is Numpy slicing. Yeah, let us just go through this concept very fast. And slicing in Python means taking elements from one given index to another given index. So we pass a slice instead of an index like this. We always have a start and the end of slice, and even we can add a step. So this is basically the syntax for slicing. And we are saying if we don't pass a start, it's considered to be 0. So in case you are doing a slicing and you don't indicate where to start, we always start that slicing from the zero index. So again, we are told that if we don't pass, let me allow someone here. Oh, yeah. So we are talking of if we don't pass the end, again it considered the length of array in that dimension. So if at all maybe you are having an array of length 3, and we don't pass during slicing, we don't pass maybe the where to where slicing. So uh, the last the length of if the length is 3, then that will be the end. It will be, by default it will be taken as the end of the slice. I think we can just have an example here, um, where we are to slice elements from index 1 to index 5 from the following array. So let us just have these. So this is slicing. Let me just indicate that that is slicing. So I think we can just implement this with just 3 lines of code. Let me just import numpy as np. We start by defining that array, that nd array, and in this case it's called R. I like to complete this for you guys to understand. Let me just, and I can just call it numbers. There might be a conflict. So this is my one-dimensional array here, and the task is to slice from index 1 to 5. So this is how we do it. We start from I think I've already showed you how the syntax. So we're just going to take our numpy here, and then we're just going to open a square bracket here. Then we can, and then inside the square bracket we can specify the start. In this case we are starting from 1 to 5. Who can guess the output for this before even I run this snippet of code? Who can guess the output for this? Or who knows the...
Okay, by slicing, it's kind of we are cutting out some numbers. Here, so maybe we left with 2 to 5.
We start with 2. Yeah, pardon, 2.
We are going to have 2, 3, 4. It's 5. I'm not sure whether 5 will be 2, 3, 4. I'm not sure. 2, 3, and 4, but I'm not sure whether 5 will be among them.
This is Bedwell. Who thinks otherwise? Who is having a different opinion? Yes?
I'm also with Bethwell.
No, okay. Any other person with a different opinion? I think you can just try to run through these and see what you're going to get. So Bedwell is right. Yeah, so because we are starting when it comes to arrays, index start from 0. So the value of 1 is at index 0. So index 1 start from where 2 is. That is 2, 3, 4, and then 5. So we'll have 5 included in that. So that is basically that with slicing. Let me check. let me check if we have. I think you can take the one with a step. I think I can also show you how what you were saying here, that if we don't pass a start, it's considered as zero index. So I think I can show you that with this. If I fail to include one, also one here will be included. So if again I fail to, if I include one and start, and I fail to include the end, all the values from index 1 will be printed out here. So that is what we meant by saying if we don't pass the start, it's considered as zero, and if we don't pass the end, the length of the array, like the end will be the length of that array. I think that is basically that with slicing. We don't have much in slicing. Yes, Wema?
Why is 6 not included?
Okay, then. In the previous example, or in which example?
Yeah, the first one. The range from 1 to 5 in the array.
Yes, let me where is oh, that's ghosted. It's here. So you're asking in which example?
Yeah, just that one. Slicing. The one you're having. The one that yeah, that one.
Oh, this one.
Yeah.
We didn't I think when I ran these, 6 is included.
No, the first one, the one that Bethel gave an answer for, from 1 to 5.
Oh, 1 to 5. This one.
Yeah.
So this one we are saying that we are starting from index 1, right? Where we have index 5. So, and in array we start from index 0. So 0 will not be included. That is 1.
Yeah.
So we are going to start from index 1, right? So this one will be index 1, 2, 3, 4. And then we have, we have 6, right? But
yeah,
we are talking of what? The end should be at 5. Let me see this. We have 0, 1, 1, 2, 3, 4, 5.
yeah.
The 6 is not included. So what was the output for this? So maybe this is the one. Does it mean that? Okay, let me just confirm some here. With the arrays, we start from index 0. Let me see this. Just a minute. Also, we are saying that note the results include the start index, but excludes the end index. So this is basically what we have. Yeah? Does it mean the end index is not included? I think that is what we have. I think we can just let me just have a look, but that should be, I think, the case. Let me just have we can always check these things from the documentation. It's quite easy when you check. That's why we always have this documentation of these libraries. Let us check from our web. Just have where we have slicing. Have iterating. Let me check here indexing. A question? Another question? I think someone is requesting to. So let us check the indexing, the basic indexing here in arrays. We are talking of a single element indexing, what exactly like that for other standard Python. It is zero based and accept negative indexes. So this one being the zero index. Okay. So slicing and striding. We are talk of basic slicing extends by the Python basic concept of slicing to n dimension. Basic slicing occur when object is a slice object that stop step. Integers. I think we are omitting the last. It should be up to the end minus 1. So if it is 5, we are going to stop at 4. Is what I was just trying to take. We are talking of assume n is the number of element in the dimension being sliced. Then we are talking of then if I is not given, its default is to 0. I think we have seen that. And n minus 1 for k less than 0. So it's not given. So I think we have seen that. And then we have default to n for k is greater than 0 and n minus 1 for k is less than 0. Not k given. Yeah, I think we are omitting the last the stop. We have the start and the stop. So the stop is n minus 1. like in this case, I thought it is get back here. Yeah, I think this should be, where is this note? I think we should add that the end should be what? The end should be n minus 1, so that now we can have, if we are tracing from let's say 1 to 5, we are going to include from index 1 to 4. Should be like this. Let me just say slicing of we have this, that is 1 to 5. This is implying that we starting from 1 to n minus 1. I think that now is making sense to all of us. Having added that information, quite good. Any other question in that regard? So if we are slicing from 1 to that is 1 to 5, from index 1 to 5, we including the, let me just go back to this example here. Yeah, we are starting from now we are going to start from, this is index 0, we have 1 2 3 4. Since now the our last index is 5, which is the n minus 1, 5 minus 1, which will be now 4. We're going to stop at index 4. So 0 1 2 3 4. I think that now makes sense. So it is up to the nth element minus 1. Wema, are we good now? Wema, I think
Yeah,
Wema asked
okay.
the question. Are we good?
Yeah, thanks.
Yeah. So it is up to the nth element minus 1. I mean the nth index minus 1, which should be now 5 minus 1. So we should stop at index 4. And I think that should be applied when maybe we want to slice up to 6. And that is now when we have our 6 is now included. Thanks, Wema, for noting that. So you were checking at what you were at. Yeah, I think we have just finished with slicing. We can even add a step. Let me just try to add a step here of 2. I think I can print this without step and with a step. let us just try to print these. So the step just shows the numbers that we are the numbers that we are going to omit. So let us just have that example with with the step. So you can have that is 1 to 5. It should be numbers. So you should have also this one with step. Let me allow someone here. I think you can add a step of 2. Yeah, let us have a step of 2 here. So the first output is it quite straightforward. But now you want you want to check even this. We can let us just add a step of 1 here and see the kind of output we are going to get. So you get that you get by default the step is always 1. That is why we don't have we don't have a difference of when we add a step of 1 and when even we omit this um, we omit this step, because by default the step is 1. Let me just remove this and have the reprint now. So you notice that the output with a step of 1 and without step they are the same. But now if I add a step of 2, I'm omitting 3. Let me just add this to up to 7 and see that you see that I'm omitting that is 3, and I'm also omitting 5. So basically that is the purpose of now step adding a step. And that is just quite easy. If I add a step maybe of 3, you notice that I'll have now at that point I'll have two numbers. That is from 2 I'll omit like 2 numbers here. That is 3 and 4 will be omitted. I think that is the purpose of step, just to omit the numbers that maybe you want to omit. So I think having said that, we can move forward to shape of an array. We can always check the shape of an array. These are just basics, so you will have to apply these arrays somewhere else. So you must be familiar with these basics. So the shape of an array is the number of elements in each dimension, and I think to get the shape of an array, it's very simple, because you use there is there is a function to again get that. So I think we can just have, let us just have just one example to check the shape of this two-dimensional array here. It is quite straightforward. I think we can, let us just check the shape of these. We can just have this print. To check to check the shape, whereby we have we have two, is it two columns? No, we have two rows and four columns with these. So this is the shape. You can even maybe try and remove this one. So this one is again a one-dimensional array. So you can just check this where you have 1 by 4. It's just quite easy to check the dimension of an array using Numpy. So we have that explanation when we got the output as 2,4, which means that the array has two dimensions, where the first dimension has two elements and the second has four. These are just quite straightforward things. Is there anything else that I'm forgetting about that? I don't think so. So can I have just someone to create an array with 5 dimensions using using the nd min. Again, this one is a parameter that we pass. It's quite simple to do that. We always pass this nd min to create an array with a certain number of dimensions. So I think we can have this example here. Create an array with 5 dimensions, and even try to check its shape. We can have the import first. Import number is the np, and then we just have to invoke that np dot array, and then we pass some values here, and then we can create using this parameter here, nd min. We can just check the kind of the kind of I think I should add something here. Just to create a 5-dimensional array should also remain maybe 4. So if I happen to check the shape of this array, you notice that I'll get it's a 5-dimensional array. It's the shape of this array is 1 1 1 think we are missing something here. But this is the kind of an array. Indeed, it has 5 dimensions, because it has how many? It has um, it has 5 columns. That is what we're getting from here. But I don't think this is the array that we wanted. You can just check something here. So just a simple question. So a 5 dimensional array, does how many elements should a 5 dimensional array have? Any person who has an idea of how many elements should a 5 dimensional array have? Because the reason why I'm getting so many brackets here is simply because I have passed insufficient number of elements that a 5 dimensional array have. So who has an idea of how many elements should 5 maybe the minimum number of elements that a 5 dimensional array have? Any person who has an idea?
Maybe 5, the minimum.
The minimum should be 5. Who thinks otherwise? Yeah,
I think it should be 5 also.
should be 5.
Yeah.
Uh, you don't have any other opinion? Any person who thinks otherwise?
I think the dimensions could be 5, but maybe the elements could be more.
Yeah, I think that is a better explanation. That is what we are basically saying here. We just need the ND mean, uh, just to indicate the minimum number of elements that um, uh, as an array with a certain number of dimension have. So in this case, you are just trying to do what? To to create these an array with 5 dimension using the ND mean. I think we have seen the output that we did get. So that is always what you can do whenever maybe required to create an array with a certain number of dimensions. So using the ND mean, just to mean minimum, ND minimum. Um, So what else should we go through here? I think we can check. We can even reshape these arrays. And by reshaping these arrays, what you need is just to just pass in an array, and then you specify the how you want that to how you want to reshape that array. You can pass even like I have an example here. This is converting a 1D array with 12 elements to a 2D two-dimensional array. I think we can have this example here. It's quite straightforward again. This is a one-dimensional array, and it has 12 elements. That is from 1 to 12. I think you can reshape that with a 4x3 array. Let us just copy these and try to see the output of these. We didn't print these. Just print these. So we are getting a 4x3 matrix. That is 3 to 4 to indicate the number of rows, but again 3 to indicate the number of columns. So this is by this function we are just trying to reshape these these array from a 1D array to an array with at least multiple rows and columns. So you can even change this one to maybe something like 6. I said 6 and 2. Just see what we got here. Whereby again now we have an array with 2 columns and 6 rows. So use the reshape function to reshape arrays. But I don't think there is someone who will ask you to reshape an array. But it's good to know. Let me see what we should check next. I think we checked at iterating these arrays. I think you can check iterating arrays using the ND iter. It's a method that is again used for iterating through arrays. So the function ND iter is a helping function that can be used from very basic to advanced iteration, and it is of some with now these the ND iter. I think iter is just a short form for iterating. With this, we are going to avoid now the nested for loops. So that is why we are calling a helping function. So it will save you time for creating some nested for loops. We are talking of iterating on each scalar element. So in basic for loop, iterating through each scalar of an array, we need to use a for loop, which can be difficult to write. I think most of us have seen that, whereby even we are having two nested for loops. I think iterating through a three-dimensional array now, it is simplified to one line code, whereby you are just going to define your three-dimensional array and then just use one for loop with the help of ND iter. I think you can let me just have these. And, let me just replace where we are having two nested for loops here. I think we can do away with these, and now you can use these, whereby we are just passing it is just for x for each and every element in this array here, and that is now why we're using our np dot nd iter, and then we just pass in our array. And if I happen to just print the value of x here, you notice that I'll get the same output. I'll get the same output as I was getting with these nested for loops. So NumPy have these functions that will help you to simplify everything. So the more you learn, the more maybe things will get simpler or easier to work out. So mostly for beginners, we use the for loops, the nested for loops. But now when you get to maybe is it advanced level, no, an intermediate, now you start using the ND iter. It's quite simple and also time saving. It will save you the hassles of writing so many for loops. I think that is the ND iter can be complex. It can also be complex, where you pass in some flags. I think we can check an example here. So iterating array with different data types. So we are saying that we can use the that is the what we are talking of. We can use data types argument and pass it the expected data type to change the data type of elements while iterating. I think, yeah, we are told that NumPy does not change the data type of an element in place where the element is an array, so it needs some other space to perform these action. And we are saying that that extra space is called a buffer, and I think all of us knows what is a buffer. But it's something new. So we are saying that NumPy do not change data types, and that is true. the elements in place. So now to carry maybe out or perform that action of maybe changing changing or changing data types, we need an extra space or an extra memory that is called buffer. And in order to enable it in ND editor, we pass a flag that is called buffered. So this is where we are talking of ND iter being can get complex, especially when you start now passing these flags. But at least we can have an example just to iterate array as a string. So let us just have this. This one is a perfect example. This is a perfect example for iterating an array as a string. So in here we start by defining our array, and then sasa we are going to have we are going to have now our n iter, nd iter, whereby we are going to pass our array, and we are going now to pass flags. And in this case, we have so many flags here. It's only that we just need the buffered one. So it's flag, and then we just have to specify the kind of flag that we want to use, that is buffered. And then we're going to specify the data type that we want to. So in here we just want to iterate this array as a string. So again we have the op underscore data type, which we want to specify by s. I mean this is a string. But I don't think again this is quite relevant in this case, or at this level. But again, it's good to know. It's good to know this. So if I happen now to run this code, you notice that I'm getting the B1, the B2, and you notice all these numbers, they iterated as strings. I'm hoping that you still remember that a string is always within quotes. But again, we have indicated that it is in this buffer memory. So we were just trying to iterate these arrays as a string, and to achieve that, you have to introduce flag, and you have to introduce the op underscore data type. Maybe you'll find cases where you need to change those arrays to some other data types, and that is where you're going to use the flags buffered. and also the OP underscore data type. I don't want to say that it is rare, but if you are required to do that, this is how we achieve that. Just remember our flags and the OP underscore data type. So that is just one instance of ND ITA being complex. But I don't think it's quite complex as such. But you can always use it whenever it is required. Don't want to discourage anyone. So we are saying that we can use filtering and filtering followed by iteration. So let us just see that. I think these are other complex part of using ND ITA, whereby we can use filter and then we iterate. So in this case, we just want to iterate through the filtered the filtered elements in maybe a certain array. I think it is quite it is quite straightforward, because you're just going to include the slicing part, like in this case where you are to iterate through every scalar element of two-dimensional array, skipping one element. I think this one also is a good example. It's quite this one is not quite difficult, because we're just passing the slice inside this ND ITA. So let us just have this example here again. So in this case, I want just to iterate through after filtering by skipping one after skipping one element in this array. I just want to print to print the left elements, and I think you can see here whereby I was having now 1 to 8. So I'm skipping one element after every iteration. So that is 1, I skip 2, I go to 3, I skip 4, I go to 5, I skip 6, and I skip now I'll skip 8 to go to 9. But in this case, I have up to 8. So these are the cases where you can modify your ND ITA. So any question up to that point? I think I was a bit fast, but I needed us to at least cover this Numpy with one lecture. And I think we have achieved that, because I'm in the last bit. Of enumerated iteration using NT enumerate. So any question with ND iter. I think they are quite straightforward. But if you're stuck, you can also reach out. You can reach out. Any question? If there is no question, I think we can go to ND enumerate. And enumeration simply means a sequence of a number, a sequence mentioning maybe a sequence number of some things one by one. So it's kind of counting one by one. So sometimes we require a corresponding index of the element we're iterating. I think we have seen that. And the ND enumerate method can be used for those use cases. So I think we can have an example to showcase that. Now, when you are told to enumerate 1D a 1D array, like the one we have here with 3 elements, that is 1 to 3. So we use the for IDX, and then let us just have this example. It will be easier having just one example here. With this, we're going to start this with again importing let me just add an indentation there. So this is the array that I have, that is 1 to 3. And now I want to, let's say you are told to enumerate these one dimensional array here, and you want like to enumerate these with the index. So it is just quite easy, because now you are going to add these the IDX the IDX. This is just ID for X, and then X, and then in np dot enumerate your array name. So this is just quite again straightforward, because what we're simply doing here is that in np, and np is our number here, has a method that is called nd enumerate, and that method is what we pass our array here, and we want to we are just interested with iterating these elements together with the indexes. So when I come now to print, I'll print index, I mean ID for X, and then the X element. So this is basically like helping us to also include the these index here. That is why I told you guys that you always start from index 0 going downward. can have even yeah, you can have even a two-dimensional enumerate two-dimensional array, even three-dimensional array. Just using the ND enumerate array. And I think that is the end of Numpy. At least we have covered every bit. But again, I'll have to share with you this link. I think I should even let me just copy this link to um to these notes so that you guys can you can take this is the documentation. Documentation. Let me just call it Numpy documentation. Just right here. Anything that you feel that you need documentation should be documentation. Anything like anytime you feel that you need to know something about NumPy, you can always check from this this document. Yeah. So any question regarding what we have covered today? Any question? Are we good up to that point? Yeah, I can see Raban telling me that we're good, and even Sharon. So by the end of today, you should have your second assignment on Python, and the marking for the first assignment is the other way. I think I have marked like, is it 5 or 6 assignments, but the marking is other way. You will still get your results for those of you who are asking about the results. If there is no question, any question, I think I can just take the next 5 minutes. I can take any question from you guys. By the end of tomorrow, you should have you will get the link for assignment 2. So do you have any question? A concern? So I think we can just drop off. No question. So you guys have a good weekend, and also make sure that you will submit your assignment on time. I think this is the reason why we are having so many delays in even you getting the results for those assignments, because there are still those assignments for SQL I'm still marking, because you guys you did submit late. So always make sure that you do your assignment on time. That is what that will grade you. So you guys have a good night and also a good weekend. Let us meet on Monday. Bye.